Hi everyone, in this video I want to do one more review example. I want to make sure we talk about at least one word problem. So here I do have a function represented by a formula, but there's also a context to this problem. So function C inputs the ground speed of a Boeing 747 and it outputs the airline's cost per passenger to fly that plane across the Atlantic. So we're just going to walk through and evaluate the function and evaluate the inverse and find the average rate of change. And then the new thing here is just going to be explaining the meaning. As you can see, I'm a little ahead of myself here. I started writing without starting the video. So if we would like to find C of 400, we just need to make sure we plug the 400 in for our x's. So we'll get 100 plus 400 over 10. So we can knock off a 0. We're getting 40. And then 36,000 over 400. We can knock off a couple of zeros. Maybe I can do math in my head today. Is that 9 times 4 is 36? Yes. So it looks like we're getting 100 plus 40 plus 90. So 190, 230. Okay, so again, we have had some really messy, challenging examples with evaluating functions, so that's nothing too crazy, but I want to talk about the explain the meaning part. So here, we've just said that x is our input, and that's the ground speed of the plane. So this is a ground speed, and I didn't say in the problem, but let's say we're doing miles per hour. And then this is supposed to output the airline's cost per passenger. So this should be a cost. So the meaning of this input-output pair is that if the plane is flying at 400 miles per hour, if the ground speed of the plane is 400 miles per hour, then the airline's cost per passenger will be $230. Okay, so there's the first one. C inverse of 220. Okay, so I wanted to throw an inverse in the mix here just to really keep enforcing this idea that the relationship between a function and its inverse is this flip-flop. They do exactly the opposite. So if the original function inputs ground speed and outputs cost per passenger, its inverse will input cost per passenger and output ground speed. So basically this is telling me that the cost is 220. So you can go ahead and set up an equation and find the inverse of this thing. So you could say x equals 100 plus y over 10 plus 36,000 over y and try and solve that for y. I think that's doable, although messy. I would say it's easier for us to just say we know the value of the c of x, the cost. Let's go ahead and just solve with, instead of having two variables, with the 200 over here. Okay, so that looks like a mess, but I actually think this works out fairly well, although I don't know if I believe I left myself quite enough room. Let's go ahead. One big thing is going to be to clear fractions, but I think I'm going to go ahead and subtract the 100 first, just because that combines kind of nicely. So I have a 120 equals x over 10 plus 36,000 over x. So if I want to clear fractions, I'm going to multiply both sides by a 10x. Okay, so I have 1,200x is equal to, the 10's cancel here, so an x squared. The x's cancel here, so 360,000. Okay, so the x's cancel, but I'm left with 36,000 times 10, so that's where I'm getting this 360,000. It's now quadratic, so let's set it equal to 0. All right, and then factor or use the quadratic formula. With big numbers like that, I think a lot of people will go for the quadratic formula, but let me just say that I actually think I was kind of nice to us. If we look at this, we want factors of 360,000 that add up to negative 1,200. I think if we do 600 times 600, we'll get our 36. 1, 2, 3, 4 zeros. Yeah, so 600, x minus 600 times x minus 600 should actually equal that. So again, if you get stuck, it's completely legal to use a quadratic formula, but that one does actually factor nicely. Okay, so we got that if we set this thing equal to 220, we got x equals 600. So the explain its meaning is if we want the dollar cost per passenger to be $220, we need the plane to have a ground speed of 600 miles per hour. Okay, last part of this one, average rate of change from x equals 500 to x equals 600. And then what does that mean? So we actually have part of this information. We know that when x equals 600, c is equal to 220. So let's see if we can calculate for the 500 as well. When x equals 500, we get 100 plus 500 over 10, which is 50, plus 36,000 over 500, which is 360 over 5, 72, I do believe. Okay, so 150, 222 is what we're getting, which means our other point is 500, 222. Okay, so average rate of change, again, remember the calculation part of this is just calculate slope. So let's do 222 minus 220 over 500 minus 600. Okay, so we're getting 2 over negative 100 negative. Okay, so negative 200ths. And sometimes for the interpreting, the decimal's easier, and sometimes the fraction's easier. So if we want the fraction, it does reduce a little bit, negative 1 over 50. Okay, so what you want to remember here is that our function was inputting the ground speed, and it was outputting the cost per person, the dollar cost per passenger. So if we calculate a slope on a graph of a function that's doing this, we're going to get a change in cost over a change in speed. Deltas are really common abbreviations for change in something in math. So when I look at this, even if I take the decimal, I'm going to think about it as a fraction so that I have that numerator and denominator to interpret. So the decimal is saying that if the speed changes, and since I have the negative in the top, we'll say increases by 1 mile an hour, the cost per person should decrease by 2 cents. Whereas this one is saying if the speed increases by 50 miles an hour, the cost should decrease by $1 per person. So actually, I think either one of those are fine. So I'm just going to go with the decimal. I want to say a little bit more info about that. One is it's not spot on perfect the way an actual slope of a linear function is. It's just an approximation of how fast it was changing. So either say, when you're explaining this, either say it increases or decreases by 2 cents per person on average, or approximately something. Just make sure that I can tell that you know that's not perfect. And it's also really good to specify what interval you calculated this on. So we were looking at ground speeds between 500 and 600. We would not necessarily, in fact, likely would not get the same average rate of change if we pick different speeds. So let me see if I can put it all together. I would say that if the plane has a ground speed between 500 and 600 miles per hour, we would expect the cost per passenger to decrease by approximately 2 cents per person for every 1 mile per hour increase in ground speed. Something along those lines would sound great. All right, thanks for watching.